Okay, today we are going over 9.4 rational expressions. So what we're going to be looking at is simplifying rational expressions. So we're going to have to divide out common factors. So what we're first going to be looking at is any restrictions on the variable. So what that means is we're going to look at the denominator and we're going to say that cannot be equal to 0. So we're going to start out with the restrictions of x squared plus 9x plus 20. That cannot equal 0 because it's in the denominator. So I'm going to factor this. I'm going to say what multiplies to c, my term here, my constant term, and adds up to b, my linear term. So the two terms that multiply to 20 and add up to 9 are 4 and 5, and we can go straight to the two binomials because the value of a is 1. So when we do our t-chart here and solve, then x cannot be negative 4 and x cannot be negative 5. So those are the restrictions on the variable. Then we can simplify this by also factoring the numerator. So the numerator, we say what multiplies to 25 and adds up to 10. That's going to be x plus 5 and x plus 5. And if we wanted to check that we factored it correctly, we can FOIL this out and we'll get back to this trinomial. The bottom, or the denominator, we already factored to be x plus 4 times x plus 5. And then we can cancel out x plus 5 over x plus 5. And we're simply left with x plus 5 over x plus 4. And that is our simplified answer. Okay, moving on. Simplify each expression, state any restrictions on the variable. So again, we take the denominator and we say that cannot be 0 to find any of the restrictions. So here, since it's all monomial, x cannot be 0 and y cannot be 0. And you can look at this logically saying, okay, if x is 0 and I plug it in here, it will make my entire denominator 0, right? 9 times 0 times anything will be 0. 0 times anything is 0. If your y is 0, 0 times anything is 0. That's why x cannot be 0 and y cannot be 0. Okay, so moving on here, we need to remember some properties of exponents. Anything over itself is going to cancel out, so the y's cancel. If I have a negative 27 over 9, that will give me a negative 3. And then I know that if I have a variable and it's the same base and I'm dividing, I keep the base and I'm going to subtract the exponent. So 3 minus a 4 is going to give me negative 3, x to the negative 1. And when we have a negative exponent, I bring it down to the denominator. So that will give me negative 3 over x, and that is the simplified version. So I have negative 3 over x with these two restrictions. And that's all. Okay, this one over here, again, two trinomials that we have to factor out. So the denominator, I think, should be pretty straightforward for us. We say what multiplies to 6 and adds up to negative 5. We do that because the value of a is 1. The number in front of x squared is a 1. So I go straight to the two binomials and I say the numbers that multiply to 6 and add up to negative 5 are going to be negative 2 and negative 3. Negative 2 times negative 3 is 6. And negative 2 plus negative 3 is negative 5. So I can find my restrictions now because I know that what the denominator is factored to be. I say that cannot be 0. I do my t-chart here, and x cannot be 2, and x cannot be 3. Those are the restrictions. Okay, for the numerator, the value of a is not 1. So when the value of a is not 1, it is a little bit different where we have to say a times c. So I'm going to go 2 times negative 2 is a negative 4. I just did a, this number here, times c, this number here. I got a negative 4. We have to say what multiplies to negative 4 and adds up to b, which is negative 3. Okay, so since it has to add up to a negative number, then the higher absolute value will be negative. Negative 4 and 1, because negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So now what we're going to do is we're going to replace this bx term with the 2 that we just found, which is negative 4x plus 1x. I'm going to replace that here. So we'll rewrite it as a 2x squared minus 4x plus 1x, or you could just put x, I'll put 1x, minus 2. Okay, so now we say, what can we take out from the first two terms? They both have a 2 and an x I can take out. When you take something out, you divide it out. So I'm going to have an x minus 2 left over. And then for this one, I have to have the same binomial left over. So the only thing I'm going to take out here is a plus 1. And then I look to see, okay, what did I make both of these have in common? I made them both have an x minus 2. And then I'm left with, if I take out an x minus 2 here, I'm only left with a 2x. If I take out an x minus 2 here, I'm only left with a plus 1. And that's factored. So we'll make that so that will be in the numerator as x minus 2 over, and then times 2x plus 1. We cancel out the x minus 2's, and we're left with, coming over here, we have a 2x plus 1 over x minus 3. And that is our simplified version. So notice that you had to take the denominator and find the restrictions before you cancel out, because now the x minus 2 is no longer in the denominator. So make sure you find your restrictions before you simplify. Okay, moving on to multiplying rational expressions. So when we multiply these two, we're going to do a similar thing where we're seeing what we can cancel out, and we still have to state any restrictions. So we can start with our restrictions here, saying that we're going to take both of the denominators. Those cannot be 0, so x cannot be 4. And here we want to look to see if it can be factored. X squared plus 8x plus 15. That cannot be 0. So we factor this. And we say 5 times 3 is 15. And 5 plus 3 is 8. So we have x plus 5 and we have x plus 3. We make our t-chart. Sorry, a little messy, but we're probably used to that by now. X cannot be negative 5 and x cannot be negative 3. So we have 3 restrictions. Our restrictions are x cannot be 4, negative 5, and negative 3, in any order you want to write those. Okay, so we already have this denominator factored. This one you can't factor anymore, it's linear. So let's move on to this one here. Alright, so we want to say a times c, 2 times 3 is a 6. And what multiplies to 6 and adds up to 7? Well, that's a 6 and a 1. Alright, as 6x plus 1x, because I'm going to replace this 7x here with the 2 factors that I found. Alright, so I have a 2x squared plus 6x plus 1x plus 3. Now I look at the first 2 terms, and I say I'm going to take out a 2x, and I'm left with an x plus 3. And then remember, when I look at the last two terms, I have to have the same thing left over, x plus 3, so I'm just going to take out a plus 1. Then we look at these two being broken up by the plus. They both have an x plus 3, and when I take out an x plus 3 here, I'm left with a 2x plus 1. 2x plus 1. Okay, so that's the numerator being factored. This one here is the difference of two squares, we should have noticed, because we have a difference and they're both perfect squares. So we'll have an x plus 4 and an x minus 4 for that one. Okay, so let's put it all together now, where we're going to have everything factored and then we can see what we can cancel out. So the numerator here, we just found that right here as an x plus 3 times 2x plus 1 over an x minus 4. Then we have this one being factored, we're multiplying it, so times x plus 4, x minus 4, all over this one we factored over here as an x plus 5 and an x plus 3. Okay, so now since we already found our restrictions, we can go ahead and cancel things out. If it's in the top and in the bottom, we can just cancel it out right away. Okay, so we have x minus 4 here and an x minus 4 here. That cancels. We have an x plus 3 over an x plus 3. That cancels. And that's it there. So after we cancel things out, we're left with, in the numerator, a 2x plus 1 times an x plus 4 over x plus 5. And this is our simplified version. If you want to multiply out the numerator, you can, or you can just leave it as factored form like this. Okay, we could do one more on multiplying, and then we'll move on to dividing. So let's see here. We're going to factor these out, and keep in mind the difference of two squares. We're going to use that one a lot here. So this is a difference, and they're both perfect squares. So I'm going to write it as a plus 2 and a minus 2. This one is also a difference of two squares because it's a difference and they're both perfect squares. A plus 1 and a minus 1 times, I have a plus 1 in the numerator here, and in the denominator I can take out an a, so I'm going to factor out an a and I'm left with a plus 2. Okay, so remember, before you go ahead and cancel anything out, we do have to find the restrictions. So we take all of the denominators, a plus 1, a minus 1, we can put them all together here, an a, and a plus 2. These cannot be 0, so this is finding the restrictions. We set each one equal to, or not equal to 0. So a cannot be negative 1, a cannot be 1, a cannot be 0, and a cannot be negative 2. So these are all of your restrictions. You can leave it just like that for your restrictions. Okay, and then we can go ahead and cancel some things out. So we have, let's see here, an a plus 1 over an a plus 1, that will cancel. We have an a plus 2 over an a plus 2, that cancels. And that looks like all we have. So once we cancel everything out, we are therefore left with a minus 2 over a times a minus 1. And this is now simplified. Okay, moving on to division. So working with division here, let's look at something simple as 2/3 divided by 4/5. So we know that if we're dividing fractions, you're going to multiply by the reciprocal, which means to keep the first fraction, change division to multiplying, and flip 4 4/5 to 5/4. So you're going to have to do the same thing with these as well. That's why we're going over this simple problem first. So we have 2/3. We're going to change this to times, and then we flip this, or multiply by the reciprocal. We all know that the reciprocal, we just flip the fraction. So when we do that, 2 goes into 2 once, and 2 goes into 4 twice. And then we multiply across. 1 times 5 is 5. 3 times 2 is 6. And that's your answer for that. So either keep, change, flip, or multiply by the reciprocal. Okay, so for these, we do have to remember that we are finding restrictions. So this one is a little bit different because let's say, for example, I am doing A over B divided by C over D, okay? So right now, we have, if I rewrite this as A over B divided by C over D, right now I know B cannot be 0 because it's in the denominator. D cannot be 0 because it's in the denominator. But then also C cannot be 0 because if C is 0, it will make this entire fraction 0. So also C cannot be 0. So all of these cannot be 0. The only one that can be 0 is this first numerator. That's the only one. You can also see it as, okay, this one is in the denominator. I'll find the restrictions, can't be 0. This one's in the denominator, can't be 0. And then when I multiply by the reciprocal, this one will be in the denominator, so that cannot be 0. Okay, so to find all of our restrictions, this one cannot be 0. So we do our t-chart here. 3x plus 2 cannot be 0. 3x cannot be negative 2. So x cannot be negative 2/3. This one, x cannot be 2. Here, this cannot be 0, so x cannot be 2 again. This one, 7y cannot be 5, so y cannot be 5/7. And this one here cannot be 0, so x cannot be 4. So we have x cannot be 4, x cannot be 2. This one is repeating, so you don't have to write it again. X cannot be negative 2/3, and y cannot be 5/7. Those are your 4 restrictions. Okay, so now we're going to look to see what we can actually cancel out. So, let's see. We have let's see here. What we need to do is we need to rewrite it so that when we multiply by the reciprocal, it'll be easier to see. So I have 4 minus x in the numerator, over 3x plus 2 times x minus 2. And when I'm dividing, I'm now going to multiply by the reciprocal. So now I have x minus 2 times 7y minus 5 is now in the numerator. And then this is in the denominator, 5 times x minus 4. Okay, so now we're going to look to see what we can actually cancel out. And if we look here, 4 minus x and x minus 4, it looks similar, but it's not exactly the same. So what you're going to actually do here is, if I take out a negative 1, and I rewrite this. Okay, negative 1, if I take that out from 4, that becomes a negative 4. If I take a negative 1 out from negative x, that becomes a positive x. So this is really written as negative 1. I'm going to rearrange these as x minus 4 here. So that's the numerator now. Instead of 4 minus x, it's the same as writing negative 1 times x minus 4. So now we can actually see that we can cancel those out, the x minus 4s and the x minus 4s. So I'm going to cancel x minus 4 with this x minus 4. I'm going to cancel x minus 2 with this x minus 2. And it looks like all we're left with now is, we still have that negative 1 in the numerator here. So a negative 1. Then I have 7y minus 5 over, I have a 5 in the denominator, times 3x plus 2. And this is simplified with the restrictions that we stated earlier. Okay, let's do another division one here. So, we're looking at this one here. So, we know that the first thing is to factor them and then to remember to multiply by their reciprocal when we're dividing fractions. So, let's look to see if we can cancel anything out. We want to see what multiplies to negative 15 and adds up to 2, positive 2. Okay, let's think here. 5 and 3, and we know that if it's adding up to a positive number, we want the 5 to be positive and the 3 to be negative, because 5 times negative 3 is negative 15. 5 minus 3 is 2. Okay, moving on here. This is another difference of two squares, so I'm going to have a plus 4 and a minus 4. We're going to multiply this by, I'm going to take out a 3 here. I'm putting this in the numerator now because we have to multiply by the reciprocal, which means to flip this second fraction. And I have an a minus 4 left. And then I'm going to divide that by a plus 1. So, taking the restrictions, I know that I cannot have a plus 4 times a minus 4. This one cannot be 0. I know this one cannot be 0, and I know this one cannot be 0. So a minus 4 is already written, so I don't have to rewrite it. But I do need to put in a plus 1. All of those cannot be 0. I solve all of these. A cannot be negative 4. A cannot be 4, and a cannot be negative 1. These are all of my restrictions. Okay, so now we can go ahead and cancel some things out here. Let's see what we got. We have an a minus 4 and an a minus 4. Those cancel. And it looks like that's the only things that can be canceled here. So we just will rewrite everything else. So I'll put my number in front. It's a coefficient, and we always put our coefficients first. X plus 5, x minus 3, over, I have an a plus 4. Oh, I'm sorry. This should be a's, not x's. Sorry about that. It's a little confused there. That's an a, and that's an a. There we go. So used to writing x's and not a's. So a plus 4 and a plus 1. And this is the simplified version. Okay, moving on. We'll do one more and then we'll wrap it up. So we just did a dividing one. This one you would multiply by the reciprocal, so don't forget to flip that. And then this one, we'll do this one here. Get more practice with a times c that adds up to b. So I go 3 times negative 2. That's a negative 6. And it needs to add up to a positive 5. So we can say we want to list all of the factors there. And nothing works for that one. So that cannot be factored. Because if we list these, we have 2 and negative 3, negative 2 and 3. Negative 1 and 6, 1 and negative 6. Oops, so this one here, sorry about that. That one can be factored. 6 minus 1 is a 5. So this is the one that we're going to use. So we rewrite that as 3x squared minus 1x plus 6x minus 2. And then we look to see what we can take out from the first terms. We have an x that can be taken out from both. So we have a 3x minus 1 left. And then we have to have the same thing left over here. So I'm going to take out a plus 2. And then we'll have a 3x minus 1 left here. Then they both had 3x minus 1's in them, so I have a 3x minus 1, and then we have an x plus 2 left. So that's the numerator factored. This one here, we will do 3 times 2 is a 6. And then we say what multiplies to 6 and adds up to a negative 7. That's a negative 1 and a negative 6. So we're going to replace that bx term and simply get 3x squared minus 1x minus 6x plus 2. So again, we look to see what can I take out here, an x. We're left with a 3x minus 1 here. We need to take out a negative 1 here, a negative 2 here, so then I'm left with the same binomial left over. So I'll take out a negative 2 and be left with a 3x minus 1, which is the same binomial. We'll take out that 3x minus 1 and be left with an x minus 2. Okay, so when we rewrite these, I have a 3x minus 1 times x plus 2. The denominator here cannot be factored, so we just rewrite that. It's times, this is a difference of 2 squares, so I have an x plus 5 times an x minus 5. And then this one is factored to be a 3x minus 1 times an x minus 2. Okay, so before we go ahead and cancel anything out, we know that we have to say that the denominators cannot be 0. So when we do that, we'll have x cannot be from this one, x cannot be 5. From this one, x cannot be 1/3. And from this one, x cannot be 2. And those are all your restrictions. Now we'll look to see if we can cancel anything out. And we can, 3x minus 1 and a 3x minus 1. And then we have an x minus 5 and an x minus 5. These are not the same. X plus 2 and x minus 2 are not the same. So we'll just rewrite those as x plus 2 times x plus 5 all over x minus 2. And this is the simplified version with these as our restrictions. And that will cover the section of 9.4 rational expressions.